These can be just regular notes, guys. They don't have to be in Cornell note form. They're all just examples. So we're just doing straight examples right now. So Unit 0 was the Pythagorean theorem. Can anybody tell me what the Pythagorean theorem is? Caleb, do you remember? A plus B equals C? A squared plus B squared equals C squared. That's what we're doing here. So make sure you title your notes Unit 0. Put the Pythagorean theorem in there. Maybe put a box around it, because that's the big thing for us right now. Pythagorean theorem. Pythagorean and theorem.
Thank you.
You're welcome. Pythagorean theorem. A squared plus B squared equals C squared. So here is example 1. I give you a triangle. One leg is 12, one leg is 16, and the hypotenuse is C. Okay, so we have legs of 12 and 16, so that's our A and our B. So to set this up, we're going to write 12 squared plus 16 squared equals C squared. This is why I wanted you guys to get a calculator out. You should have some of these memorized. We do have the common square roots up on the board. Can somebody tell me what is 12 squared? 144. How many of you have that memorized by now? Good. Does anybody have 16 squared memorized?
I do.
What is it?
256.
Good. 256 equals C squared. So what I want you guys to do is add 144 and 256. Somebody tell me what you get.
400.
Thank you. 400. So 400 equals C squared. Now, is that my answer?
No.
No. Remember, we need to get C by itself. Right here I have a C squared. What would I do to get C by itself? Square root it. So take the square root of both sides. And then you can use your calculators on this. Remember, on your calculator, to find the square root, let's find that square root button. It's the little yellow one right here. So you type in 400. You hit the shift button, because remember, that's what we hit for the little yellow one. And then you hit the square root, and what do we get? 20. So we get C equals 20. There are no units, so we can leave it just as the number 20 and then put a box around it. So let's look at what happens if I give you the hypotenuse and a leg, but you're missing the other leg. So example 2. We have our triangle's upside down, but how do we know which one's the hypotenuse? It's the long one. So this leg is 6. We call this leg X. Remember, that little square means it's a right triangle. And then our hypotenuse is 15. So here's what I want you guys to do right now. Plug it into the Pythagorean theorem. Double check with your neighbor to see if you got the same thing. Here's what I got. Our first leg is 6, so that's going to be 6 squared plus, what's our second leg, guys? X. So that's going to be X squared equals our hypotenuse, which is 15, and make sure you square it. How many of you got that correct? Excellent. If you did not, make sure that you rewrite it. Remember, our hypotenuse is always the one on the other side of the equal sign. And I remember on this test, a lot of you, the only reason why anybody missed this problem is because you forgot to square every single thing. So make sure that you're squaring every single thing. Okay, so here's what I want you guys to do. Find 6 squared and find 15 squared. Okay, guys, what's 6 squared? Okay, so that's 36 plus x squared equals what? 225. Good. How many of you have 15 squared memorized? I have only up to 15. I don't have 16 or higher yet. Good. Okay, we need to get the x by itself. So what would you do next? I have 36 plus x squared equals 225. Any ideas? Yeah, subtract 36. And make sure that you're writing down the minus 36. Because 36 minus 36 gives me 0. So that leaves me with x squared equals 189. And then the last step is to do what? Square root it. So take the square root of both sides. I'll tell you guys right now it comes out as a decimal. So will you please round to the nearest 10th power? 10th. That's the first decimal place. What'd you guys get? 13.6. Did anybody get anything different? 13. Can I see somebody's calculator? 13. It comes out to 13.74 or something, right? 189 square root 13.747. If I was rounding to the nearest tenth, we look at the next one, and 4 does not cause us to round up, so our answer comes out to 13.7. Good. So, I have a 12-foot ladder set up 5 feet from the base of a building. So that's going to make a triangle. So the first thing I want you all to do whenever you have a problem like this is to draw a picture. So here's my building. We're just going to draw a line. Here's my ladder leaning up against it. And so this bottom part's going to be the ground. Let's look at the information they give us. A 12-foot ladder. If my ladder is 12 feet, what is that measuring? Is that measuring one of the legs, or is that measuring the hypotenuse? The hypotenuse, because our ladder is leaning up against the building. So label that 12. And then it tells us it is 5 feet from the base of the building. So where is 5 going to go? On the bottom, that bottom leg. So what am I actually looking for? The second leg. What do you guys want to call it? A, B, X, B? Okay. So here's what I want you guys to do. This problem is very similar. Here's your right triangle. To problem number 2. With your groups, I want you to solve for B. Okay, so to set this up, we should have got something like B squared plus 5 squared equals 12 squared. Thumbs up if you agree. If you flip-flop the B and the 5, it's okay. It's the same thing. Okay? So that's going to give me B squared plus what, ladies and gentlemen? 25 equals 144. And then what do I need to do? Good. So subtract 25, and we get, I'm going to move my work over just a little bit. B squared equals what? 119. And then what would I do? Square root it. So what did you guys get for B? 10.9. Now remember, this is a word problem, and our ladder is measured in what? Feet. So you need to put 10.9 feet. Thumbs up if you got that correct. Fantastic. Okay, example 4. Same thing. You don't have to write all the words. The reason why I put this problem in here is because you will see one like this on your homework. So I just want to make sure that you know what the vocabulary means. Okay? So example number 4, let's adjust. It says use the converse of the Pythagorean theorem to determine if the triangle is a right triangle, and then wants you to explain your answer. Converse means going backwards. So this time they give us all of the measurements, but we don't know if it's for sure a right triangle. So we have to plug everything into Pythagorean theorem to check to see if it's true. What would be your hypotenuse in this one? The 15, the biggest one. So we should get 8 squared plus 12 squared equals 15 squared, and we're checking to see if we get a true statement or not. Okay, so that's what the converse means. It means that we're going to go backwards to see if this is a right triangle or not. Okay, So guys, what is 8 squared? 64 plus, what's 12 squared? 144 equals 225. So what I want you guys to do is add 64 and 144. What do you get? 208. Is 208 equal to 225? So is this a right triangle? No. How come? Yep, because it doesn't fulfill the Pythagorean theorem. So no, it is not a right triangle. Because, let's just say a squared plus b squared did not equal c squared, okay? So that's the kind of explanation you need to give, because Pythagorean theorem didn't work, because a squared plus b squared did not equal c squared, because the leg squared did not equal the hypotenuse squared, something like that. Okay, so example 5, they give us 2 points, and they want us to find the distance between those 2 points. So let's graph the points first, and we'll see what we get. -3, +1. That means I'm going to go from 0, 0, left how many spaces? 3, and then I'm going to go up 1 and put a point there. And then how do I plot the point 5, -6? 5 right, and then down 6. So your other point should be right here. Draw a line between those 2 points. And then do you guys remember what we did on these problems? Calculated the slope. Now before that, your instructions are going to be use the Pythagorean theorem. So what could we do? Yeah, you draw a triangle, right? Close. Yeah. So draw a right triangle. And then let's label the distance between the points our hypotenuse C. So we need to figure out the distance of our legs. So what would this leg be? 7. You can count the spaces, 1, 2, 3, 4, 5, 6, 7, or we can subtract 1 and -6. What about this leg? It's going to be 8. Caleb, how'd you get that? Just counted. Okay, guys, so use Pythagorean theorem on this. That's going to be 7 squared plus 8 squared equals c squared. Solve this with your groups. Round to the nearest tenth if you get a decimal. All right, so we get 7 squared is 49 plus 64 equals c squared. What's 49 plus 64? 113. And then what's the square root of 113? 10.6. We don't have any measurements here like centimeters, inches, feet, so we can leave it as 10.6. Okay? Okay, we're almost done with Unit 0. And then we have Unit 1 really quick. Okay, example 6. Rectangle ABCD has a length of 18 centimeters and a width of 10 centimeters. So what do you think you guys need to do? Draw a rectangle. So if our length is 18, that means this is going to be a tall one. So I'm going to draw a tall rectangle. Really, it's just a sketch, so it doesn't have to be perfect. But label it A, B, C, D. Okay, so our length is 18 centimeters. So label your length or your height 18 centimeters. And our width is 10 centimeters, so label that 10. And then they want us to know the length of the diagonal AC. So that's going to be this diagonal. So what are you guys going to do? So it's going to be 18 squared plus 10 squared equals, what do you guys want to call it? C? C squared. Yeah. Okay. Finish it. Find me C. All right, guys, what did you get for 18 squared? 324 plus what? 100 equals C squared. So that's going to give me 424 equals C squared, and then what do we do? Square root it. What's the square root of 424? 20.6 what? Centimeters. Good. If you forgot centimeters, make sure you put it in because our problem did give everything in centimeters. Okay? Any questions on Pythagorean theorem? Okay, we have one more problem, and this was those 3D boxes. You guys remember the 3D boxes? Yeah, I know. I know. So, let's look at the 3D boxes, and I'm going to give you the formula. So, if you remember, the formula for the diagonal of a 3D box, D stands for diagonal. D squared equals length squared, that's a cursive L, plus W squared width, plus height squared. That's your formula. Put a box around it. This is the formula you guys are going to use. It's not volume. Volume is length times width times height. We're adding them all together. Really, if you guys remember when we did this, we had to do Pythagorean theorem twice. So what this all comes out to is Pythagorean theorem twice. So now let's look at what is given to us and plug everything in. It has a length of 12 inches. So where are you going to plug that in? For L. So I'm going to leave everything blank except for L, and I'm going to plug in 12 squared. It has a width of 4 inches. So where are you going to plug that in? W. So plus 4 squared. And then here's why I left everything else blank. The length of the three-dimensional diagonal of the box is 14 inches. So where are you going to plug in 14? For D. So we're going to get 14 squared plus equals 12 squared plus 4 squared, and we don't know what H is, so plus H squared. So you're just plugging in what you know. Okay? All right, so do all of the math. Find me 14 squared, find me 12 squared, and find me 4 squared. All right, guys, what's 14 squared? 196 equals 144 plus 16 plus H squared. Okay, do 144 plus 16. So I get 196 equals what? 160 plus H squared. And how do I get H by itself? So that gives me H squared is equal to 36, and then what do? Square root both sides. So what do we get as the height? 6 what? Inches. Not so bad, right? So what you need to do is you need to make sure that you have this formula memorized. Length squared plus width squared plus height squared equals the diagonal squared. Okay? That's why I have you put a box around it. Unit 1 had to do with functions and then independent and dependent quantities. Independent, dependent is what we kind of had trouble with, so I'm going to give you definitions kind of in my words so that we can help ourselves a little bit easier. So independent quantity, make sure you write this down. So independent quantity, okay, I don't know why I wrote an X. Independent quantity is what you as an individual controls. So put something like that in your own words. What you have control over. Or what you as a person can change. For example, you have control over how many hamburgers you eat. You have control over how many pages you write for your homework. You have control over, I don't know, what else? How many cupcakes you bake, okay? How many hours you work. Your dependent quantity is what changes when the independent quantity changes. So dependent quantity is what changes when the independent quantity changes. So for example, if we're talking about your grade on the final and how many hours you study, which one do you have control over? Do you have control over what your grade is, or do you have control over how many hours you study? How many hours you study, and your grade depends on how many hours you study. Does that make sense? Okay, so here's your first example. You don't have to write all of the words, just pay attention and write down what the independent and dependent quantities would be. So here is the problem. Hector knows there's a relationship between the number of cars he washes and the time it takes him to wash those cars. What is the independent quantity and what is the dependent quantity? So independent quantity. And dependent quantity. What does Hector have control over? Does he have control over how many cars he washes, or does he have over the amount of time it takes total? Think about it. He's the one washing the car. So does he determine how many cars, or does he determine how much time? Well, let's say it takes him 10 minutes to wash each car. Which one is he controlling, guys? Which one? Can he stop at 5 cars if he wants, or can he just stop at 1 car if he wants? He can stop whenever he wants. So what is he controlling? The amount of cars. So his independent quantity is the number of cars. The amount of time depends on how many cars he washes. Does that make sense? So the dependent quantity is the time, or the amount of time. Okay. Okay, example 2 is similar, but this time they give you a graph. Same thing. I maybe suggest that you sketch the graph, do it as best that you can, but you don't have to write all the words. So I'll read you the problem while you're sketching the graph. David rode his bike to the park. After staying at the park for a few minutes, he then continued his ride to the grocery store. The graph shows this relationship. In the graph, what is the independent quantity and what is the dependent quantity? The x-axis is how much time he was away. The y-axis is the distance that he was from home. Okay, so this first part of the line is telling you that as he's riding his bike, he's getting further away from home. But as time passed, he stayed at the park, so his distance didn't change. And then he goes to the grocery store. Okay. Okay, guys, what is David controlling? Is he controlling how much time he is away from home? Or is he controlling the distance that everything is from his house? He's controlling the time. So the independent quantity is the time. And this time they give us a measurement, so make sure that you write time in minutes. So when they give you the measurement, make sure you include it. So he's controlling how much time he's away from the house. So then what's the dependent quantity? His distance. Distance in what? Miles. Okay, remember on the graph, your independent quantity is always your x-axis. Your dependent quantity is always your y-axis. Okay? Okay, example 3. Remember, we talked a lot about functions in Unit 1. We had a special test to determine if something is a function. Does anybody remember what it's called? The line, but what type of line was it? A vertical. So this was the vertical line test. And basically, the vertical line test, if you take a vertical line, which is straight up and down, you can only touch the graph in one place at a time. So here's what I'm going to have you guys do. For parts A and B, just sketch the graph really quick. The numbers don't have to be perfect. I just want you to draw a little sketch so you know what it looks like. So the way that I do the vertical line test is I always use my pencil or pen, and I just kind of pass it left to right through. So looking at part A, does my vertical line ever touch more than once? Yeah, so is this a function? No. No, not a function. Okay, because remember, if you are ever touching more than once, it does not pass. So look at part B. Is it ever touching more than once? No, so is this a function? Yes. This line is very, 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 very steep, but it never actually touches more than once. Okay? Okay, last thing we're going to do is we're going to look at different types of functions. First, we're going to classify if each of our functions are increasing, decreasing, or constant. So what I'm going to have you guys do is write out each of the examples really quick. Just give yourself a line next to it even. You can just go next to it. And we're just going to write if they are increasing, decreasing, or constant. Okay? So guys, remember when we did this unit, I gave you a packet. It had, I want to say, 2 or 3 pages on it, and we cut out all the little graphs, and then we glued them onto each page, and we had linear functions, quadratic functions, exponential functions, and what was the other one? Absolute values. Do you guys remember this? It had, yes, Jonathan, can I borrow that? It was this one. If you have it, so we had linear functions, and then we talked about the standard form, if it was increasing, decreasing, minimum, or maximum. We glued some examples onto it. If you have it, get it out. If not, you will need to find it at home, okay? So I'll give you a second to try and find it. Okay, so all we're doing for example 4 is increasing, decreasing, or constant. So look at 4a. F of x equals 3x. Can you guys tell me which type of function this is? It's a linear. Now, remember, with linear functions, we look at the number in front of the x. This one is positive, so is it going to be increasing or decreasing? Increasing. So it's actually going to be a line that looks something like that, and it is increasing. Okay. Part B. Because it's a positive number. If it was negative 3x, that would be a decreasing. Now, part B, f of x equals negative 2 to the power of x, and then I have to write where x is an integer, because this is what type of function? Exponential. Now, if our number has a negative attached to it, our exponential function looks like this, where it starts really high and then gets lower as we go on. So would that be increasing or decreasing? Decreasing. So in an exponential, if your number is negative, it is decreasing. But exponentials were very, very special because look at this one. Is this also an exponential function? Yes. But our number is positive, but it's a decimal. So is it increasing or decreasing? Also decreasing. So it also looks like this. So if your exponential has a negative number or a decimal or fraction, they are both decreasing. You are only increasing if you have a whole positive number. Okay? So exponentials are tricky like that. You should have that written in your packet. Okay? What about f of x equals 1/5? There's no x's in there at all. So what kind of function is that? That's a constant function. And it's actually a horizontal line. It looks like this. Okay? So constant functions are just numbers. There's no variables at all in there. All right, part A. I don't know where the F went. That should be f of x equals negative 7x. Yeah, typo. Okay, f of x equals negative 7x. What type of function is that? Linear. How do we know? There's no exponents, it's just a number and an x. Is this one increasing or decreasing? Decreasing, because it's a negative 7. Okay, so if we were to graph it, it would look something like that. Okay, f of x equals 3x squared. What type is this? That is a quadratic, because anything to a second power is a quadratic. It looks like the U, it's a parabola. So that is called a quadratic. Okay. What about f of x equals negative 4 to the x? What's that? That one's exponential. And the difference is that in C, your x, or your variable, is in the exponent. In B, your exponent is just a number. Okay, so the difference between a quadratic and an exponential. Is this exponential increasing or decreasing? Decreasing. So it looks like this. Last one for this, f of x equals 8. Linear. What type of linear function is it? It's a constant, but it's still linear. Okay, so even though it's constant, it still graphs as a line. Okay? Okay, guys, look at part A. Negative 4 and those bars x. What type of function is that? That's an absolute value, but because it's negative, is it making a V or is it making an upside down V? Upside down V. So this tippy point right there, is that the highest, the maximum, or is that the lowest, the minimum? It's the maximum. Hold on. Let's finish. F of x equals 2x plus 5. What type of function is that? Linear. Now, a linear function, does it have a maximum or minimum? No, because it goes on forever. So none. C, there's an x squared there. What type of function is that? Quadratic, and because it's a positive, it's going up like a smiley face. So does that have a minimum or a maximum? A minimum, because it has a lowest point. And then D is an exponential, which is increasing forever and ever, so it has none. Okay?